In this very short video, I'm going to say a few words about a technique called conservative garbage collection that can be used for languages like C and C++. To review, automatic memory management relies on being able to find all the reachable objects. And it also needs to be able to find all the pointers in an object. Now, the difficulty with doing garbage collection for a language like C or C++ is that it's very difficult or even impossible to identify the contents of objects in memory with 100% reliability. So if we see two words in memory, it might be a list cell that has a data and next field. So if we see just two words here, and there are some bit patterns in here, zeros and ones, okay, how do we know whether these are both pointers? I mean, it could be that one is a pointer and the other is not in the case of a list cell. So one of these fields is just data, like an integer, and then another one is a pointer. Or it could be something like a binary tree node where both of these words are pointers. And because of the weakness, really, of the C and C++ type systems, we just can't guarantee that we know where all the pointers are. Now, it turns out that it is possible to extend garbage collection techniques to work with languages like C and C++. And the basic idea or insight is that it's always okay to be conservative. If we're not sure whether something might be used in the future, then we'll just keep it around. And remember that graph reachability is already a conservative technique. What we really want is to keep around the objects that will just be used in the future, but the reachability in the object graph is an approximation to that, so because reachable objects might be used. And now the problem with C and C++ is that we don't know where the pointers are. We don't have a guarantee from the type system about where the pointers are. And so the basic trick is that if something looks like a pointer, then we will treat it as a pointer. All we have to do is be conservative, and if we are not sure whether a given word of memory is a pointer, then we can just treat it as a pointer and keep whatever it points to around. And as long as we're not going to move it or change it, that will be okay. And so how do we decide whether a particular word of memory is a pointer? Well, it should be aligned, meaning it should end in some zeros to indicate that it was pointing, that if it was a pointer, it was pointing to a word boundary. And then whatever bit pattern it is, if we interpret it as an address, it has to be a valid address. So it should point into the data segment. And notice that these two conditions will rule out all kinds of data in memory. So for example, any small integer is probably not going to be interpretable as a valid address in the data segment. So most likely, only things that are pointers, or very few things that are not pointers, will be treated as pointers. And what we're going to do then is, if it looks like a pointer, we're going to consider it to be a pointer, we'll follow it, and then we'll end up overestimating the set of reachable objects. We may keep around some stuff that isn't reachable at all, but that's all right. It's always okay to keep around more stuff than necessary. Now, we still can't move the objects, all right, because we can't update the pointers to them. If we don't know that something is a pointer, we certainly don't want to change it, okay? And, so for example, if we thought something was a pointer and it was actually an account number, and then we updated the pointer when we move the object, we would just completely change what the program does. So this only really works with mark and sweep.